Lulu. Welcome back. What's up? Today off from school, nice. How are you? I'm doing good. I have a little bit of time here, so I thought I would jump in and make some progress, hopefully. It's kind of like people are home being sick right now, so we'll see how much time I have. Because last time I think we worked on, still working on the bindings. Yeah, the mutables. Yeah, that's right, the mutable variables. And that's right. So I think kind of what the solution was. Yo, Penguin, what's up? To the problem that we have was basically the value was represented differently in different circumstances, but now the value is represented as a pointer, basically. While you have this mutable variable, it always is like a kind of like a reference to the value, so it's like a pointer to where the value is. So it's stored in the closure as a pointer now, instead of being stored as the actual value itself. And because then it has the same kind of makeup, so that we don't need to kind of worry about it being different in different circumstances. So now the issue is that we are treating closure pointers differently depending on how it's used, and that is not great. So when we resolve a location that is a closure, I think we're always making them, we should always dereference them. So does this work? Okay, well, this dereferences the location. However, the thing is, like, it could already be dereferenced. Actually no, because if it's dereferenced, we're getting stuck here. So here's like an undereferenced closure. We always dereference the closure. The problem is, though, is that we need to, because what we need to do is we need to turn this, when we encounter a closure, we need to turn it into a heap pointer instead and dereference that, probably, like at this stage here. Otherwise, when we do this, whoops, and we get a closure, we kind of have to dereference twice. I think we probably want to do this, actually. We'll have a special case if abs is closure, then we want to turn it into a heap pointer, but also dereference it once. So let's get So that should this should this should get to the address and then dereference that. And we don't really care about the dereference flag at this point. So that should be good. Okay, so then we get our value inside, which should be a pointer. I think now it's like always a pointer, or maybe not actually. But I guess it doesn't matter. So we got this, and then we say that if we also want to dereference, we want to return that yeah, the modification doesn't make sense here. So yeah, so if it's a closure and we want to dereference, we want to actually dereference twice. So that's what we're doing here. Otherwise, we'll return the dereference. Right. So now this can also be... Wait, but it is... Wait, what do you actually return? Oh, a pointer. I mean, it does make sense, maybe. Also, you're a pointer as well. Yeah, okay. It's like when we use this, we don't really need to modify the value, apparently. So, all right. Now, are we done? I forgot a little bit on. Okay. On what we were doing here. So let's run this in the debugger. See what's going on. Okay, yeah, that is the mutable variable. And then we set that to be the pointer to that. Okay, so if we look at the heap now, we see that this is the closure of the main thread. So this is where the local variable is stored here. This is where the value of it's stored. Okay. And now when we do this, it should dereference. Okay, so now the stack, you can see the result is stored on the stack here. And now we're setting this to that. I think that's where the issue was before. Now let's look at the heap now. Oh. Oh, so it should be set. to wait. Oh, this points to the heap. Okay, it should be set to. Okay, we should dereference this. Okay, but we're actually there now, I think. So binary arithmetic. No, wait. No, this is assign. Okay. So the problem here is that here we get like we could get like a pointer type. And also, I just realized, I didn't think about this at first, but I just realized that making it this way, like making it like in an IR way, was actually way more complicated than I first thought. Because I was like, well, we could just like these things, like a mutable variable that we assign and we do some expressions. Like it's actually way more complicated, especially if you, let's see, because sometimes, like let's say you were working with an assembly language, you have to juggle things like, general registers, general purpose registers, or the stack, or things like that, to actually accomplish what you want to do. And it's actually, it's pretty ridiculous sometimes. The kind of complexity that grows from just a seemingly simple thing. But I think it's also more complicated in this language, the way that I've done it here with the virtual threads and the sharing of the variables between them. So we also, see later if that probably leads to some more issues later on, like timing issues, like race conditions and stuff like that. We'll see though. We'll see. I think it's mostly gonna be if you're spawning things in the background. Like you could potentially spawn a block doing something in the background that modifies outside variables. We just have to make sure that the lifetime of those live there. But we don't even have garbage collection. So right now it's not a problem. But later, when we have like garbage collection, we have to make sure that everything is like ref counted or something. Alright, so left and right. Yeah. So the thing is, like, right can really be anything at this point. Like, it can be a compile time known value. It could also be a pointer. And so when we're setting this, we're setting it to a pointer. That doesn't really make sense. We're setting it to a pointer on the stack. That does not make sense. Like, if we're setting this to a pointer on the stack, I think we want to dereference that. Because it's like we're setting something else that might have longer lifetime than that stack. So it doesn't make sense that we would have a pointer to the stack here. So I think in that case, I'm just gonna say, like, if this is stack location, then I'm gonna modify this Okay, if it's location and if abs is stack, that is true. And then we had the results. You know what? Let's do on this instead. Let's do the reference here instead. Okay. And then we'll do write.source equals write.source. There we go. Okay. Whoa. All right. Cool. Let's try this again. And now we're setting, so let's look at the heap. We can see this is the actual variable value here. So now it should be set to 10. Still not. Okay, it's still set to the pointer to the stack. And this is not dereferenced, so that's weird. Okay. Oh wait, no, it's not a stack location. Actually, it's a ref. Okay, so let's do or there we go. Hello, Hack Dog. What's up? Welcome. Okay, now we can see it got these brackets, so that means it's dereferenced. And now the value has been updated properly. Awesome. And we got some leaks, I think. No. Print info window. Okay, whatever. It's like a bug in the debugger, whatever. So yeah, cool. Let's see if we can do +y as well. So I want to see. Okay, now we get an issue. Okay. Is so alloc1. Right, that's the setup of the. So here's the closure, and here's the variable x, and now we're creating a ref for some arithmetic result. X plus 5 is 10. Okay, so now 10 is stored at this stack here, location here. So that's the same as before. Now we're creating a second, now we're pushing another one, which is gonna store this plus 3. And I think this is the issue here, because this is not dereferenced. So that is the issue here. We need this to be dereferenced, because this is gonna fail, I believe. Yes. Okay. So that's the thing. Like, I mean, I think we want to dereference these anyhow, so we compile them. Well, left. No. Both should be dereferenced. I'm just gonna add this convenience function here. They should always be dereferenced. I mean, what I want to do is that I want to say that this will work if it's a compile time value. This will not like do anything basically. If it's a location, it will dereference. So no results. And so we'll do if self source and that's a union enum, right? No, it's not. Wait, isn't it? It's a union enum, yeah. So if this is a location, we'll return, we'll do a copy and we'll set you to dereference and we'll return that. Otherwise we'll just return self. I'm like 1 semester in IT. Why are you making scripting language? It's mostly for fun, and if I succeed, well, it's for fun and a learning experience. And if I succeed, I will also get a language that I can use. Because I'm making a language that is gonna, for me at least, replace Bash scripts that I write myself, basically. And the reason for that is because I'm tired of looking up Bash syntax, and I don't want to like study it and have it in my head, because I don't write Bash scripts that often, and every time I do, I have to look up this and that and everything. So that's why. Okay, so now we have that. And now we have this. Good. Okay. And we can also go to assign actually, and I think we always want to dereference right at this point. Maybe. I'm not sure actually. Yeah, I mean, I guess let's do that. Oops. Okay, let's see how this works now. All right. I think here was the issue. So now this is dereferenced. Okay. And here's the result that's stored in the stack, on the stack. I mean, we should really probably pop the previous before we do that, because the ref just kind of hangs around. Like, it's a temporary result. I guess we could have like a consume function or something. Well, we'll see. It started to come together here a little bit, yeah, actually. Okay, and then we set this to that. And let's inspect the memory. Whoops. And here we can see that X is properly set to 13. So it all works. Awesome. Okay. Now let's try and actually print this now. So I'm just gonna demonstrate that this should work. It doesn't, okay. Could not dereference value of u integer. Okay, why are we trying to dereference this now is the question. Is it because it's on the... but it's a constant though. Okay, I'm gonna try x. Okay, that actually works now. Okay, so now it's flipped around. A constant doesn't work, but the mutable actually does work. Okay. So why does this not work? Let's see what's happening under the hood. So here we're setting the... okay, so now we should look at the heap. Okay, now we're over here because these are taken from the read-only data, so we're over here now. And so here's still the closure for x. X is stored over here. X is 13. Y is... actually, this isn't y though. I'm not sure where this comes from. I guess that is the... no, wait. That's the... maybe this is the closure for... no? The other fork? But where is... why is it over here? It should have like closure space. Oh wait, no. 6 is the closure space, right. And 3 is the value of the first element, right. Okay, yes. Okay, now it makes sense. Because it's a constant, so it's not pointing to a mutable space. Okay. And then what we do is we clean that up. Here we're creating the string. We're setting R to 2. That's how many elements there are in the string rope thing. And wait, yes. Yeah, so now we're setting R. We're setting R to be the pointer to the string. We're setting the first element of the rope to be an empty string. That is expected. Okay, and now we're setting this to be the dereference of this closure of the first closure. And what is the first closure? Well, the closure is at 6, which we can see at over here on the stack. And then so 6 is 3. So this should, well, this is okay. This is where the issue is. So it's gonna try and dereference the number 3 here. That is the issue. Yeah. So I guess constants. I guess when you have a closure like this, if it's a constant, we don't dereference the closure. But how would we know? that. So I think it's like compile identifier. So if it's mutable, we do a dereference. No, it's like when we declare the closure. If okay, it's kind of weird because we have separate things going on, because the inner closure could reference, so okay, if this was in a block here, okay, we're creating a closure for the block and for the echo. Y is referencing this Y, so it's stored both in this closure but also in this closure. However, this closure is having the actual value of Y, while this closure has like a pointer to the previous closure, I'm pretty sure. Or it's like a closure, yeah. So that doesn't really work because we want them to have the same makeup, because otherwise we can't really reference the same thing the same way. So I mean, it's a constant, so we could just store the same value over and over. We don't actually have to have a pointer to the previous scope here. I don't think. We could, since it's a constant, it never changes, so we could just store it as a value instead. So it's like, here we're storing a closure value, we're declaring it, and now that should be fine. This is fine, I think. The thing that's not fine is, wait. No, yeah, the declaration is fine. It's the, when we create the variable, when we populate it. So we populate it, for example, here, and we create this thing, and then we also call this thing over here, which will insert a bunch of instructions, and here is the issue. So here is where we are looking up these things, but the thing is, if it's mutable, we do this, but if it's constant, I think what we'll do is we don't dereference. Perhaps. No, this should just be stored as the value. We don't actually, okay. Declare. No, it's not gonna be here. Where is this happening? My mind is kind of wondering what's going on here. Okay, so we compile identifier. We look up if it exists at all. If it doesn't exist at all, we have an executable. If we find it in our local scope, we just return that. And depending on if it's mutable, we dereference it or not. Okay. But then here's when I'm getting a little bit confused right now. So we declare the closure value. What does that do? That will add it to the closure list and declare the thing. And we also undereference the location as well. So that... Okay, but then we return the location as the reference though. And we return that as a thing. Why? I don't think we need to do that. Let's just try and not do that. Okay, I'm not sure what this is gonna do, but maybe it works. We'll see. Let's see. There. Okay. Ref set arms. All this should be the same. Okay, let's look at the heap here. Okay, that looks good, I think. Yeah, so, and then let's continue in here. All right. So we're setting, it's kind of hard to see here, but we're here now. Maybe I should try and make this a different color or something. But this one is setting here. Yeah, I think the closure saved. Yeah. So now let's see here. You are setting that to R, so that is the created. Now that's the handle. Yeah. Yeah, because now we're in a block, so we have like one more thing that we need to worry about. And then we allocate something here. That's the closure, right? And we're setting that to R, yes. And we're setting that. Okay, let's look at the heap now. Okay, so here you can see that we're basically just copying this constant value. So this is what I would expect. This is the closure of the block, and this is the closure of the executable call. All right, and now we're setting that to something there. We're forking. So now we're forking to the executable call, and you're creating the string. You are resetting that. We're allocating the string. We are setting R to be 2. That's right. The string length. You are cleaning up after the. No, wait. You are setting the string pointer. Yes. And now you're waiting. Okay. Now we should only have 5 and 2 going. So set R to the pointer again. And now we're setting the first element to empty string. That's expected. We're setting now. Okay. We're setting now R plus 2 to C plus 0. So now you can see it's not dereferenced anymore. So if we look at the heap now, here is the string, okay, and it has two elements, 1, 2. The element are an empty string, and then number 3, which is expected. So now this should, hopefully, this is going to work. So that is the pointer to the string, I believe. Yes, yes. And then we're pushing echo. And then we push the number of arguments. And we execute. And we wait for the stream, or... No, we wait for the process to exit. We do this a couple of times. We should see somewhere the echo. Here we go, echo 3. And now it's just doing some cleanup here and exit. There we go. Awesome. So if we run this, we can see that we get a 3. So let's do like y equals that, x equals x. Oh my god, it didn't work. Wait. Okay, okay. Interesting. Okay, so well, let's remove that and just focus on x, because I believe this should work now. No, it doesn't. Okay, so because I want a more simple example to see what's going on here. So that's good that it actually didn't work there. Okay, because the calculation should all work. Okay, and now we're creating the closure. Yes, and we set that. Okay, so let's look at the thing. So here's the closure of the first. Here's the x. Here's the closure of the second. So now it actually points to that. That is correct, because it's immutable. Okay, and you are allocating some stuff. All right. Now we're creating the string, and we're setting this to c plus 0. So c plus 0, c is 6, plus 0 is this. So it is setting it. It is pushing this pointer now, which is wrong. It should be dereferenced at this stage. Yeah. So that is wrong. Because now this is like a pointer to the thing. It should have copied the value. Okay. So that is when we compile this identifier, it was undereferenced. Or, well, it wasn't referenced. Which is weird, because it's mutable. It should have been dereferenced. Also, now we can just do local binding. Whoops. Result reference. What's your line called? Runic. All right, so okay, let's say it's not going in here. Let's say it's over here. And then we're doing this. I think we need the same kind of like if it's mutable, we dereference, otherwise we don't. I believe that is what we're doing. So dereference is equal to is mutable. I'm just gonna throw that, see if it sticks. I mean, I'm pretty sure this should work now. Unless we broke something else. So let's see. Empty string. Yeah, now this is the reference. That is correct. Let's take a look at the heap. So first closure X value here. And this is the closure. Actually, it copied the value. That is not correct. Okay, so this should crash now. Yeah. Because that was not correct. Right, it's like when we store it on the closure, we shouldn't dereference it. It's the other. I think it's the other way around, maybe, or it's like depending on how you use it. Like when it's copied to the closure, when the closure is populated, it should dereference it if it's constant and not if it's not constant. I think, or just this. And then when we want to use it, I think we just copy this logic here. If it's mutable, we will return this dereference. There we go. And about the 100th time, I said there we go, and we never know if it works or not. Okay, let's inspect the heap after all that. Okay, now this is correct here. Alright, so we set that empty string, we set that to dereference. That is correct. And we can see here that now this is copied properly here. And we execute, and let's continue. All right, so let's just run this, and there we go, it works. Yes, hello Samath, welcome back. Hello Sekiro, welcome. Thank you, Hackdog, for the follow, by the way. I'm really bad at reading the notifications. Okay, let's add a block here to see if this works. This works, okay. Now, moment of truth. Does this work? Yeah! Okay, so awesome. Okay, we've got mutables. Okay, another moment of truth. Does it work? Does this work? Like, okay, let's set this to x plus 2. So, whoops. This should be 15? Hey, okay. Let's see if it actually changes the original x. So let's put a thing here. And there we go, yes. I'm speaking to people on Twitch as well. Awesome. So, cool. This all works. I believe I had like a block thing, block bindings. This works now as well. Awesome. Okay. Wow, so it just works now. Cool. All right. Wow, that was unexpected. Like, it just works. And we have mutable variables. Awesome. Okay. Can we grab something else? Man. Some of these that seemed like super easy in the other version, now that we have an IR, seems like, okay, now I really have to go in and really think about what this means. But yeah, so the main things that we want to have is like functions calls, obviously. I think we already kind of have like a very, very basic function call. Yeah, this works. And I'm gonna try and do that. This also works. Okay. And I'm not sure, I don't think this works. No. Unsupported expression, okay. Okay, yeah, so we have like basic function support, but we need to kind of implement more stuff there. For pipelines, we want to have and an or. That shouldn't be too difficult. It's like some of these things is like when we have the puzzle pieces, some of these things should be very straightforward. Redirections is going to be a huge thing, I think, that we don't really have right now. This is fixed, so there we go. For loops, of course. I don't think that's, well, actually this might be more than I think, because of the iteration stuff. Like the iterators, it was pretty easy to do it in the other, like in Zig, but then making the for loop in the IR is probably a bit harder. Is this game development or practicing coding zig-like? This is not game development right now. This is, well, I guess it's practicing coding zig-like because you're kind of practicing it. Any language you're writing in, you're basically practicing. But yeah, it's mostly to make this language right now, this custom language. All right, and then we have binding to different things like the executable calls, for example. which is not possible right now. We can say, for example, echo hello. This should be bound to E. Okay, and if we run this, we can see that it actually just echoes it out. It doesn't actually bind it to E. So it just compiles this, but we don't have, because in the previous iteration of the language, we kind of have like, we set up a context so that when you bind something, this doesn't actually output to the outer context. It's like in a separate context. So at this point, we don't really have this functionality so that we can have a separate context to bind this to. Because this shouldn't happen now. It should only happen if you're trying to like echo this out later, like this. But this is an error, I think. No, it's not. Okay, it doesn't actually do anything. Okay, so I think E is basically like nothing. What is the best programming meme you know? I don't really look at memes too much, so I wouldn't know. Sorry. Is your name Sunil, sir? No. C++ and Python best meme. I don't know. They are not memes by themselves, but I don't know any memes. So basically you're telling that declaring should not run the echo but just a variable. Yes. So this should, well, technically it does run the echo, but it doesn't run it. It doesn't output to the outer context. It runs the echo, but it stores the result in memory instead of outputting it to the terminal directly. And then if you want to see what it actually became, or the output of it, you would have to echo the result out like this. So that is what's happening there. Okay, but yeah, I thought this was gonna take longer, but it actually turned out to be pretty not much left there. So I actually think I have to cut it short here a little bit, but yeah, we'll see what we will tackle next time. Maybe binding to executable calls, because that's a huge thing. We would need create a context when binding to things that what would that be called? Like, it's either like blocks, executable call, blocks or calls, basically. Create a context when binding to calls. That should then be stored in memory. That is stored in memory. And it's also, I think it's related to a struct, so we should also have a executable call result struct for this, probably, that we can then reason about as well. Okay, so that is, I think this is larger than it, I mean, yeah, than it seems at first. And then of course we have like function arguments. We don't really have support for arguments right now in IR. So that is also a thing. Maybe we'll tackle this next time. We'll see. It's gonna be a larger journey here, but it's gonna be really nice when it's done, because it's gonna lead to more things that we can do. From which country? Sweden. Python is interpreted by C++ and compiled. That is why there are a lot of memes on their performance, like Python's Turtle, C++ Flash. I mean, yeah. Sure. it's like, yeah, but then you can also say like, okay, well, but Python does have like, speed is not everything when it comes to these things. Like, for example, my language is gonna be probably the slowest language ever, but the point is not speed, the point is to be productive. Oh, you were asking the other person. Okay. All right. Yeah. Have a nice day. Well, I'll see you. Bye bye.